We'll have some people doing some things. Okay, so here's where we got to our problem. And what I want to do is have each group come up and just basically present ideas. Here's what we think. Here's what we think. Here's what we're stuck with. In other words, I don't want any finished product here. I want ideas here that are going to stimulate other people for thinking, what are the questions? What are the ideas? We've gotten to this part, and I wanted to ask Ms. Gilliam this question, but she wouldn't answer me. So I'm going to ask the rest of you this question because this is the one I want to get done. You may go first.
Yeah.
So the difference, so you take the radius and you subtract this number right here, so that would tell you how much, basically the distance from here to here, and then you could relate that to 1 second, and that would know how much you go in 1 second, and then you could relate that back to 30 feet.
I'm so
Yeah. What was your goal? What was your goal for the end product of what you were trying to do?
Okay, if you find this number right here,
and our question was, how fast is the merry-go-round going?
here,
Question?
I'll just go up.
Go up and do the
Circumference, and I'll need this. I fixed my
because 6 seconds is the amount of time it goes around.
Yeah. There's your rate, right there.
There's your rate. Someone else can do something.
Wait. Would you explain that?
Hey, do that math.
You find the
Find the circumference, 2 pi 7, because 7 is our radius. Divided by 6 seconds is a
it
whole
goes all the
term.
way around.
So it's like the whole feet divided by the whole seconds.
Oh, yeah,
You get
that's
a
right.
little
So you get
Feet per
that.
second.
feet per second.
So that's the
7
goal.
Yeah.
Yeah.
So now we can plug that into the equation.
Well, basically our problem is we have this, like that, sort of.
That was better.
Basically.
Okay, so we have a rectangle, and we have,
Where's the rectangle?
Where is this?
huh? Right.
Maybe if you picked
Here.
a different color of pen now instead of green, it might help us.
Alright, I got red. Okay, so this is the rectangle that we're dealing with. Okay, this line right here is the tangent to the circle. And this line right here is the radius. And since we have this, we need to find this to get this.
Okay. Does everybody see the dilemma?
Yes.
Okay, Tobin.
Can't you just find that using...
Well,
Because it's not
Wait, could you
perfectly.
read?
because it's perpendicular to this line,
Right.
and it's at the 2 o'clock point exactly where he where it's like tangent to the circle, right there, and so we can just take the 2 o'clock line and say that that's a perpendicular line to his release line. So now that we have that, we could come back to, I don't know, that picture's.
Yeah.
We have this line right here, and so we have 90 here, and
aren't those two triangles, that little triangle that's formed with a 30-degree angle and the big triangle, aren't they similar triangles? So aren't the sides...
which one? Right here and this one?
Yeah.
I don't know. We could
Since they,
try to prove it.
They should be.
they should be because they're cut with the
I
same.
say we should try to take the rate.
Both the lines are parallel.
Good game.
Why wouldn't they be?
So that means, you know, like you can find the, you know,
Wait,
the
didn't
ratio
you figure it out just
of
sitting there?
the, like
Right
the
there.
small one to the big length, and that you can find the ratio of the two sides, and you can use Pythagorean theorem to find the length.
Yeah.
This one would be 60 because 180 minus 30
Oh,
minus
yeah, that's
90
what
is
it is.
60. And then this is a line, right? So this is 180 degrees. So you do 180 minus